Hi there, good afternoon. We're starting with next topic, which is compositions with trig functions. So notice here the word important here is compositions. Something we did with compositions previously was stuff like f of g, or f composed with g, or g composed with f. Another way to write that would be f of g of x, or g of f of x. These were composition functions. We did this previously. The big idea from here was when we have two or more functions composed with each other, we always start off with what's on the inside. We evaluate this inside function, get an answer to that, and that answer now becomes the input for the outside function. These both have the same meaning, they're just written differently. And the one above it, g function, would be evaluated first. The answer of this would be fused into f function and then evaluated. So we did this previously. Now we're doing compositions with trig functions. Before I begin with this, let me remind you something important here, which were our restrictions with sine inverses, sine, cosine, and tangent inverses. Sine restrictions were quadrant 1 and 4 only. Restrictions with cosine, because of the inverses, is first and second quadrant. Restrictions with tangent is same as sine, which is first and fourth quadrant. Which means with sine and tangent, we are not allowed to get our answers from second or third quadrant. We just get them from the first or fourth. If this is the initial side of an angle, we can only go as far as pi over 2 or 90 degrees on this side, and we're only allowed to go negative 90 degrees or negative pi over 2 on the other side. Going counterclockwise are positive angles, going clockwise are negative angles. So the only direction we are allowed to follow is this or this, which means if I'm constructing a 300-degree angle, if I want to say, hey, the answer is this location, which is a 300-degree angle, again, remember, 300-degree angle is constructed going this way around. That's how we create a 300-degree angle. It's a big angle. But we're not allowed to go via second and third quadrants because of the restrictions. We would rather call 300 degrees as a negative. The direct reflection of that is 60, as a negative 60-degree angle. So we're, instead of writing 300 degrees, we're going to write negative 60-degree angle. Now, do they mean two different locations? No, it's the same location. What depends on is how we got to it. If we got to it creating a clockwise angle, those are negative angles. That's one thing to remember. This also applies to tangents. The other thing to remember is with cosine, our restrictions are quadrant 1 and 2 only. So with cosines, we do not get our answers from here when we have restrictions. We will only get our answers from quadrant 1 and 2, and with cosine it's pretty straightforward. The only messy part comes in if we are in quadrant 4, we have to rewrite that angle as a negative angle instead. But those were the quick reminders. Moving on with today's, as I said, we're now doing compositions. This is what composition looks like. You might want to write this in your notes. I'm about to create a big table here. Let's say I have sine inverse followed by sine of x. And you can clearly see this format matches our composition format. Sine inverse of sine of x. X is the input there, of course. The best part about this is that sine and sine inverse literally cancel each other out because they're inverses of each other. They cancel each other's effects. So these can be canceled out, which leaves us with just x as being the answer. However, we got to be very careful. X better be here in quadrant 1 or 4. How do I write that? That's quadrant restricted to quadrant 1 and 4. So if x is in quadrant 1 and 4, we take that answer. If it's not in quadrant 1 and 4, then we do some reflections over y-axis to get to that. If I were to swap the order, if I say, hey, sine inverse of x, sine and sine inverse can still be canceled out. X will still be the answer. However, this x is not going to be angle. This x is going to be the range. And with x and y, with sine and cosine, range is restricted between 1 and negative 1. We got to be careful with that answer. If our answer is between 1 and negative 1, we'll take it. If it's not, we'll discard it. Let's look at cosine now. Cosine inverse, cosine x. So cosine inverse of cosine of x. And cosine inverse can cancel. Our answer is x, but we got to be careful that x needs to be between where With cosine, restrictions are first and second quadrant. First and second quadrant can be restricted like this. X is between 0 and pi, which automatically refers to quadrant 1 and 2. If I swap their order, the answer will now be reflective of the range and where, I should have written that up here as well, where and where. Now x needs to be between the range of cosine parent. Cosine parent also fluctuates between 1 and -1, so this will be the same as sine. In case of tangent, we have slight differences because tangent graph is very different from sine and cosine. However, if I have tangent inverse, tangent of x, I can still go ahead and cancel the 2. Answer will be x. And where this x better be between quadrant 1 and 4 again, but the quadrantals are not included. What that means is, if you notice, I did not put that equal to sign here. That would make it incorrect. The reason tangent does not accept 90 degree and -90 degree, because they're asymptotes there with tangent graph. If I swap the order, I can still go ahead and cancel them. Answer will still be x, and the beauty of tangent, when tangent's on the outside, tangent inverse is on the inside, there are no restrictions. Anything is acceptable here. So x will be between -infinity and infinity. If you notice, I did not put that inclusive sign here because with infinity, we never put the inclusive sign because that would not make sense. We really don't know where and what infinity is. Okay, this is the table we will refer to for sine, cosine, tangent based on these examples below. But as I said, restrictions is what we have to be really careful about. And if we end up in quadrant 4 as an angle measure, we will write that angle slightly differently. We'll write it as a negative angle. Now let's look at some examples. I have a bunch of examples for you. The questions aren't that long. It's the understanding part. Let's say this is the question. Sine inverse sine of pi over 8. Now, x, all the above x's here in the table were inputs, like any input. Now I'm actually starting to give you specific inputs. Okay, and what I can do is, since it's sine and its own inverse, they can cancel each other out. That leaves me with pi over 8. Now I need to think about this. Is pi over 8 acceptable? This is an angle. Is it in quadrant 1 or quadrant 4? If it's in quadrant 1 and 4, we're good to go. If not, then we'll have to do some other things. Now, how do I know this is in quadrant 1 and 4? The first step should always be to look at the chart. Can you find pi over 8 in here? Let's clean that up. Do you see pi over 8 in here? No, pi over 8 is not directly listed here. However, it's not too hard to figure out that pi over 8 will be in quadrant 1. Pi over 8 is slightly smaller than pi over 6. It will somewhere be here. But I'll show you a trick here how to do these. Pi over 8 can be reread as 1/8 of pi, which means if pi is split into 8 parts, I'll get to the first part. Let's split 0 to pi into 8 parts. So this area, quadrant 1 and 2, need to be split into 8 parts. Because this is an even number, it's very easy to do that. 1, 2, 3, 4. And then 4 will be here, 5, 6, 7, 8. So 5, 6, 7, 8. 4 parts in quadrant 1, 4 parts in quadrant 2. So 1 refers to 1 pi over 8, 2 refers to 2 pi over 8, 3 refers to 3 pi over 8, 4 refers to 4 pi over 8, and so on and so forth. Sorry, 6 pi over 8, 7 pi over 8, and this will automatically be 8 pi over 8, which is pi. And you can clearly see pi over 8 is in the first quadrant. That's acceptable. Literally, that is our answer. So if you plug in pi over 8, we should be good to go. You probably are thinking, whoa, that was really easy. Yes and no. It can be both. Let's say here's my second one. Sine inverse sine pi over 8. And of course, since it's the same inverses, they all cancel. And I end up with 5 pi over 8. Again, always check, is 5 pi over 8 on here? No, we don't have 5 pi over 8 on here. That's when we'll have to draw our own thing. But thankfully, the previous question had the same denominator. I needed to split it into 8 parts. Pi was supposedly to be split into 8 parts. And thankfully, the previous question was just the same. So now if you look at it, clearly 5 pi over 8 is sitting right here in the second quadrant. That is not acceptable for sine. So what we do is, because this is sine, we're going to take that angle, reflect it straight across y-axis to get the correct location. So this will not be accepted, we'll discard it, and instead we'll say the correct angle referred to is 3 pi over 8. If that made sense. This was sine, and hence we reflected over y-axis. If this question was cosine, I would have reflected over x-axis. So with sine, we reflect over y-axis. Sine is the y-coordinate, so that kind of explains it. Cosine, I would have reflected over x-axis if it was not in the right quadrant. And for tangent, $1,000,000 question for tangent, we will reflect it over the origin. Oh, bless me. Sorry about that, guys. I came too quick. All right, example 3. Sine inverse. It's a sine. Let's make it 4 pi over 5. And that. Cancel. 4 pi over 5. Let's go check. Is that angle on the chart? 4 pi over 5 is not on the chart. Where will this be? Without drawing it, I know it is going to be in the second quadrant, but since I just taught you it, let's do it. How do I locate this angle? Well, please refer to this as 4/5 of pi, which means if I can split 0 to pi between 5 parts, I need to get to the fourth part. Remember, 5 is an odd number. I mean, you don't have to really remember that. You all already know 5 is an odd number. So when I'm splitting this space into 5 parts, 2 will be on one side of the quadrant, the other 2 will be on the other quadrant, and 1 will be wrapped around y-axis. And 1 and 2. So I'm going to bypass this y-axis, 3, 4, and 5. With odd numbers, there's no choice but to bypass y-axis. Because if I count y-axis, I'll end up with even number of parts. And you can clearly see 4 pi over 5 is sitting in the second quadrant. That is not acceptable with sine. Got it reflected over y-axis, and the corresponding angle to 4 pi over 5 would be 1 pi over 5. So I shall discard that answer and call it pi over 5 instead. Interesting, right? Yep. Only 1 and 4 acceptable, as I said. Example 4. I'm going to swap their order. Watch, I have swapped their order now. This is half. Right. Okay, sine and sine inverse will cancel. But before we do that, please go ahead and match it up. What format of sine is this? Sine's on the outside, inverse is on the inside. It's this one. Because the order has changed, now we are running into range. My answer better be between -1 and 1. If it is, great. Well, half. Is half between -1 and 1? $1,000,000 question? Yes, it is. So that's it. This worked out just fine. How will it look weird when it will not work out? Well, anything that's not between -1 and 1. Let's call that a 5. Ta-da! Sine and sine inverse cancel. It's like, wait a second. Because sine is on the outside, sine inverse on the inside. This should have been between -1 and 1, and clearly 5 is not between the two. So I'm going to say there's no answer. Whoopsies. This is not an angle, guys. 5 is not an angle. It's a value. Because it's not an angle, I really don't have to worry about looking at the quadrants or which quadrant is it in. Is it in quadrant 1 and 4? I'm not going to worry about that because this is a value. Then sine graph, if I were to just construct a sine graph, stops here and then keeps going, goes as max 1 and minimum -1. And I'm looking at 5 here. We're saying, hey, this is 5. Nope, doesn't work with parent function. Parent function is restricted. So those were 5 examples of sine. Let me switch to cosine. Cosine inverse, we have cosine, and we have 3 pi over 4. Cancel. And I end up with 3 pi over 4. So wait a second, this is a cosine question. Talk to yourself. Cosine better be restricted in quadrant 1 and 2. Let's first check here. Is 3 pi over 4 available here? Oh yeah, it is. It is in quadrant 2. I don't have to mess with it. It is what it is. This works. Example 7. Cosine inverse, cosine 4 pi over 3. It's like the fun part here is canceling these, and I end up with 4 pi over 3. What quadrant is this in? Always go and check the chart. You might just find it there. I did find it. 4 pi over 3 is sitting in quadrant 3. Whoopsie daisies, that is not acceptable. So this is a cosine question, guys. It's a cosine question. So I shall reflect this over x-axis to get to the right angle instead. Oops, my line got a little messy there. So 2 pi over 3 is the correct location. Also notice the cosine value here and cosine value here are the same. And that's why it's okay to pick 2 pi over 3 instead of 4 pi over 3 while getting it in the second quadrant, which is acceptable. So I'm like, oopsie daisies, nope, 2 pi over 3, and that shall work. Example 8. This one's pretty interesting. Cosine inverse cosine. 8 pi over 5. It's like, what do I do here? Well, the fun part is it's cosine inverse. I can cancel them. 8 pi over 5. I just have to make sure this is in quadrant 1 or 2. If not, then we'll do our fun stuff. Let's see where this is at. Obviously, 8 pi over 5 is not on the chart, so I'm going to figure out myself. Where in the world is it? 0 to pi. You're going to read it as 8/5 of pi. So let's have pi split it in 5 parts, get to the 8th part. Splitting 0 to 5 into 5 parts means 2 on one side, 2 on the other, 1 wrapped around y-axis. And I'm going to make this dotted to remember to not count y-axis. 1, 2, 3, 4, 5. Don't count y-axis, guys. If it's an odd number, don't count it. This is 5. So 1 pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5, 5 pi over 5. It's like, what? I need to get to the 8th part, so I guess I'll have to continue. Split the bottom also in 5 parts. 1 and 2 and 3 and 4 and 5. But continue, so 6 pi over 5, 7 pi over 5, 8 pi over 5, 9 pi over 5, and 10 pi over 5. It seems like I'm having to do a lot of work, but I am doing all this and writing the pi over 5, pi over 5, pi over 5 part over and over again until you start seeing it. You really don't have to write the pi over 5, pi over 5 every single time. Anyway, did I find the location? Yes, I did. 8 pi over 5 is sitting in the 4th quadrant. Nope, say nope. That is not acceptable. Because it's a cosine, I'm going to reflect it straight across. This will be reflected to 2 pi over 5. So nope, and 2 pi over 5 should be the right location. Idea is whatever x value is here, this angle will also correspond to the exact same x value. So I really haven't changed the value of cosine. Both angles have the same x value. So that's that. Moving on, example 9. Let's switch the order. Cosine inverse. Let's say we have root 2 over 2. If you notice, I've changed the order. So now this matches the second type of cosine, this one. And you just got to be sure that the answer is between -1 and 1. So this is root 2 over 2 between -1 and 1. Yes, it will be. You can use your calculator and you can get the value of it. The way I know is that this numerator is less than the denominator, so it has to be less than 1. Plus it's a positive 1, so it's between 0 and 1. And done. So these questions can probably just take sometimes 5-6 seconds, and they can go really fast. Sometimes you have to kind of gauge the answer and manipulate it. Moving on to tangent inverse. There we go. Well, it's tangent and its own inverse. Obviously, you can cancel them. 5 pi over 4, where's that at? Always check the chart first. 5 pi over 4 is on here. Right there. And this is tangent. I'm in the 3rd quadrant. Whoops, not acceptable. So the question is, will I reflect it over y-axis? Will I reflect it over x-axis? No, I'm not going to do either of them. Because watch, the tangent value here is 1. And if you look at the tangent value here and here, they're not the same. Tangent needs to be reflected over the origin. Straight across, actually. Tangent's cool. That's the cool guy. Straight across. we're taking it to first quadrant, and the corresponding value there is pi over 4. It's in the first quadrant, so I really don't have to mess with pi over 4. Pi over 4 it is. Pi over 4 it is. So, what did we learn? With sine, reflect over y. With cosine, reflect over x. With tangent, reflect over the origin straight across. Here's another handy-dandy example. This one's a good one too. 7 pi over 8. And of course, cancel, cancel. We're 7 pi over 8. It's not on the chart, I already know, so I'll have to draw my own thing. Splitting it into 8 parts and get to the 7th part. I hope by now you have started to see it, that this should be in second quadrant, guys. 0 and pi, I'm going to split it in 8 parts. So 1, 2, 3, 4, 5, 6, 7, 8. This is the 7th one, right? And I don't have to write all of them. Okay, here's 1, 2, 3, 4, 5, 6. What did I do? Oh, I'm sorry. I have to split it in 8 parts, silly me. So 4 here, 1, 2, 3, 4, and then 5, 6, 7. And it's just wanting to write these. Okay, clearly 7, this is in the second quadrant, not acceptable. However, because this is a tangent question, I'll have to reflect it straight across here, right? This is the location. Now, yes, this will be 8, 9, 10, 9, 10, so 8, 9, 10, 11, 12, and then 13, 14. You will say, yes, this is 15, right? 15 pi over 8. Yeah, you're right about that part. However, this is in the fourth quadrant, so I'm not going to make an angle going all the way around here to get here. Nope. We're rather going to make that angle just going backwards 1. So we're going backwards 1/8 of the fraction. So this is negative pi over 8. The way I usually go is if this is 7 pi over 8, this is just one block away from x, right? 1/8 away from x-axis. So on the other side also, this will be 1/8 away from x-axis. But since we're going the negative direction, it's going to be negative. Yeah, those are the things you got to be careful about in this one. Other than that, it's pretty much the same thing over and over again. The questions are pretty quick and short. Like tangent, tangent, inverse of 5. Yeah, cancel, cancel. But notice how tangent's on the outside. And that's the one that doesn't have any restrictions. Look at that. It's all real numbers. What you get is good to go. This was a parentheses, by the way. So 5 it is, and 5 it is. It's acceptable. Just keep referring to the chart bottom line, okay?